This video is on more properties of logs. So we just come off of like introducing a log and the basic principles of what logs are used for. Again, exponent problems. And the reason why it's the three main objectives that we're going to do in this video is how we use logs to isolate the variable that we're trying to solve. Just like in algebra, the key is to get x by itself, as we always say. And then with that, we need to learn how to condense and expand. Those are opposites, logs, like problems. How do we combine problems? How do you combine terms and things of that nature? Just like we combined exponents. And the last thing is how do we evaluate logs on our calculator using change of base. And some newer calculators have that built in. If not, we're going to show you the setup that does it on any calculator. Okay, so let's talk about log properties, why we use logs in such a manner. So what we have here is, for instance, we have 2 to the x power is equal to 8. So if I put this in a log form, a lot of people say, oh, I know what x is already. I can do that in my head, and x is going to equal 3. That's fine. So I'm going to say log base 2 of 8 is equal to x. So notice we get x by itself on the right-hand side of the equation. So logs allow us to take a variable that's stuck in the exponent position and put it in an equation and get x alone on one side of the equation. So that's the whole purpose here. Now let's look at this one here. X, or 2 to the x power is equal to 16 allows us to say, oh, well that says 2 to the 4th power, so x must equal 4. So we'd say log base 2 of 16 must equal 4. Okay, so that's, there's the x right over here. Now, that's nice if everything works out nice and neat, but what about this problem? 2 to what power is equal to 10? So we're saying, okay, log base 2 of 10 is equal to x. So here, x must be, somewhere in between 3 and 4, because 10 is in between 8 and 16, but it's 3 point what? So let's take a look first on how do we evaluate this on a calculator. So to figure out x, we want to plug this into a calculator, and this is going to be a decimal, some like 3 point something. So let's take a look to see what it looks like. Well, here's the formula that we want to use. We have log of base b of a, and the way we do it is we can type in log of a divided by log of b. Now notice, why are we doing this? Because this is log base 10. Notice there's no number written here. Most all calculators have log base numbers, log base 10 numbers inputted into the calculator, but they don't have like log base 2 numbers. So we have to tell the calculator, okay, using log base 10 numbers, how do we find out this ratio? So let's take a look at the calculator. Okay, so let's take a look first at this example right here. This is from this page, so we're saying 2 to the x power is equal to 10, and we went ahead and wrote log base 2 of 10 is equal to x. So to do this into a calculator, I'm going to say, okay, now I always like to put the base in the bottom right away. So I say, okay, this is log base 10 of 2 goes in the bottom. So that goes in the bottom, and then I'll do a different color. The top number, log base 10 of 10 right here. Okay, so I'm going to type that into the calculator. So let's pull this up. I'm going to turn it on, and we're simply say, okay, logs, this key over here in the left-hand column, log of 10, I'm going to close parentheses, divided by, and then log of 2. And log of 2, close parentheses, and not close parentheses, there we go, enter. Okay, 3.32, okay, so x must equal 3.32. So what we're saying is, 2 raised to 3.32, and I'm just, approximately, I'm rounding here to 2 decimal places, must equal 10. So let's go back to the calculator and check to make sure that that looks good. So I'm going to go 2 raised to this power must equal 10, and there it goes. Okay, so this shows you can take any base, raise it to any exponent of any decimal or a fraction, and you can get any number. So we can solve basically any problem in an exponential way using logs. Okay, so looking again at this one, here's an example. I'm just going to put in change of base form. I'm going to put on the bottom log base 10 of 3, and on top log base 10 of 8. Type into your calculator, and you get the answer. Okay. Now let's take a look at other properties with logs. What we have to be able to do is expand and condense. So we may have a problem where you want to find a log of an entire entity. So in algebra, you have to get, like, for instance, the parentheses by itself, or whatever the case is. So you want to condense things so you can isolate something. So sometimes you want to condense them. The other thing is sometimes you want to expand it because you can't evaluate a large log item, but you can evaluate smaller items. So we have to go both forms. And in the next video, we'll show more examples of where we use. The purpose of this video is just understanding the fundamentals, like literally learning how to ride a bike here. And in the next video, I'll show you solving situations when we expand and when we condense. So the thing that I like to do here is say, okay, logs. Now the thing, let's take a look here. Remember, logs are exponents. So all properties that we learned about exponents are the same for logs. For instance, if you have, I'm just going to write over here to the side, x to the third times x squared. We are multiplying bases, okay, right here, multiplying bases. So what do? We add exponents, and we say, okay, there's a total of 5x's here. So the same thing here. If we are multiplying bases, so if the bases are the same for the log, then we treat the logs with exponential properties. So like when we add logs, we're really multiplying bases. So let's take a look here. Now, just like positive and negative exponents, like bunk bed problems, all logs want to be in the numerator. Okay, and that's the nice thing about log. It puts everything in one line. There's no fractions. It's one line. So everything naturally wants to be in the upper bunk or in the numerator. So when you have a negative log, it's going to put it in the denominator. It's going to switch positions. So right here we have a positive log of m. So that's really saying log of m in the numerator. Okay, so that's the same thing as there. Whereas if we have a negative log, that's the same thing as log, and we're going to put it in the denominator. Okay, so that is the situation there. So anytime you see a positive log, it goes up high. Anytime you see a negative log, it goes in the denominator, just as like a negative exponent. So let's take a look here. So when we have an example, we have positive log m. Okay, so I'm going to combine these two. So the whole purpose is, can I condense and combine the two logs, combining like terms in a fashion. If we have a positive m, m goes in the numerator, and then we have a negative log, so that means the n goes in the denominator. So I can take the log of this fraction, and it's the same thing as these two separate logs. So again, we're combining it, combining similar to like terms in algebra. So let's take a look at some examples here. Let's go ahead and expand this. So a lot of times we see this all as one big unit, but we can't evaluate this on the calculator and solve the pieces. So what we have to do is split it up. So I'm going to see two items in the numerator. So two separate pieces. That means I'm going to two positive logs. So I'm going to have log base 3 of 6 and another positive log base 3 of x. So those are both in the numerator. Now I have an item in the denominator. I'll do it in a different color. Down here, 7. So I'm going to do negative log 3 of 7. So again, notice they're all base 3. But now I expanded. So now we could like plug, for instance, this into the calculator and get a decimal value. The same with this and get a decimal value, which leaves this x by itself very easy to solve. Okay, so that's the reason why we expand there. Okay, now here is an expanded form. Let's go ahead and condense so we get a single log term. Notice the one thing you have to look for is that all the bases are the same. So I'm going to be log base 3. Now what I like to do is, boom, set up my parentheses right away. Set up my fraction. Anything that's positive goes up top. So this is a positive, so 4 goes up top. We have a negative, so the x goes in the denominator. We have a positive, so the y goes up top. Done. Okay. So we have 4 times y. And again, everything's being multiplied because, again, exponents is repeated multiplication. So these are all multiplication and division problems. So that's the condensed form right there. Positives up top, negatives down low. Let's take a look at another property of exponents. Remember when we multiply exponents, power to power. So off to the side, I'm going to do x squared raised to the third power. Well, here we multiply the exponents and we get x to the sixth power. So we do the same thing here. When you multiply logs or numbers with logs, it's the same thing as doing a power to a power. So in this scenario here, we're taking log of m raised to the x power. That's all thought of as the same element. So what we can do is take this x, which is a exponent, a power, and I'm going to change it to a multiplication problem, 2 times 3. So I'm going to take the x and I'm going to throw it out front. So we basically have x times log of m. The key is we want to be able to get log of a single unit, because then we can put that into our calculator. So when we see multiplication of logs, it's the same thing of raising it to a power exponent. So let's take a look at example here. Here we see a 5 out front being multiplied. So that's the same thing as I can put it in the exponent position. So I could really say this is log base 10 of x to the 5th power. And when I do it, it's log of this whole item right there. You know, sometimes we don't show parentheses when we do logs. Not really sure why. I always like to put them in just so I understand exactly what I'm looking at. Here's another example here where we have, okay, log base 4. And we see an x up top here, so I'm going to put that out front. So the 5 is the only thing here. I'm going to put the x as the exponent out front, shown as multiplication. Just like this right over here. I'm taking this 3, and I'm going to throw it out front as an exponent problem. Okay, so a power to a power means multiplication. Alright, so now let's take a look at combining both expanding condensing with positive and negative logs and multiplying logs, and see a problem where it puts it all together. So here's 2 smaller examples, and it's what we'll conclude the video with. So what I want to do is expand these. Okay. So what I'm going to do is say, okay, we have log base 3. Now I see 3 different things going on here. I see a 4, I see an x, and I see a 3. So the first thing I'm going to do is split this up. This is 4 times x cubed. So this is log base 4. So that's a positive. And then the x cubed, I'm going to add it as another exponent. Log base 3 of x cubed. Okay. Again, so I'm adding exponents. Same thing as multiplying bases. Okay. Now, I want to move this 3. I know I'm done when I have a single item that I'm taking a log of. So the last thing I'm going to do here is now take the 3 and move it out front. So the 3 goes out front just to this term, log base 3 of x. I know I'm done because there's only a single item that I'm taking a log of, and it's all expanded. Okay. Now let's take a look. Here's a little bit better example. Notice we see a radical. Say, well, we haven't seen this. Well, we haven't seen this radical, but we have seen an exponent. So the first thing I'm going to do is change it to an exponent. So this is x to the 2/5. And from our last unit, we understand that we can do that as an exponent. Now that we see it as a power, I can take this and throw it up front. So we have 2/5 out front, log base 3 of x. So that's how we can take a radical, convert it to an exponent, and then convert it to a log. So really, radicals, exponents, and logs are really all 3 the same thing. We just put it in different forms depending on what type of problem we want to solve. And in the next video, we'll see examples of that as well. Now here are a couple more examples where we give it to an expanded form. I'm going to have you condense it. So let's take a look at these examples. And let's take a look here. Now, so the first thing I'm looking for, do we have the same base? This only works if you have the same base. So I have log base 3. Now, the first thing that I'm going to do is I'm going to move the 4, any multiplication, put it in exponent position. So this is really 2 to the 4th power. And log base 3 of 4 to the 3rd power. So all I did was take these numbers out front and put them in the exponent position. We can see it here and here. Now I see 2 positives, so I'm going to multiply them in the numerator. So this is really log base 3, and again this is this whole thing together, 2 to the 4th times 4 to the 3rd power. Okay. Now the nice thing is, since it's in this form, we can go ahead and figure that out. So this is log base 3. 2 to the fourth is 16, and 4 to the third power is 64. And we can multiply that, and we have log base 3. I have no clue what 16 times 64 is, so let's pull out the calculator here. And 16 times 64 is 1024. Okay, so 1024, and bingo. And again, if I want to evaluate this, let's go ahead and finalize it. Let's do the change base. So I'm going to do log base 10 in the calculator of 1024 divided by log base 10 of 3. So let's use the calculator once again and calculate this. We're going to do log 1024 divided by log of 3. And let's see what we get. 6.31. So this is equivalent to 6.31. Okay, roughly, approximately. So let's change that there. Okay, so here's another example here. I'll just do it a different color so we don't get mixed up. Okay, so the first thing I'm going to do is I like to move my multiplication into exponent position. So this is 5. Oh, I'm sorry. Let's see, erase that. Started off wrong already. Do log base 9. Again, I got to check, make sure I got base 9 numbers in both. I do. X to the 5th power minus log base 9 of y squared. Now what I'm going to do is I see one positive log and one negative log. So I'm going to combine them as a fraction. Okay. And again, I'm going to do the positive one up top in the numerator. And then I'm going to do the negative one. No, it's the negative right there in the denominator. And now I've condensed it into a log of a single item. So we want to be able to go both ways, expand and condense. Okay, that pretty much wraps up this video on basic properties of logs. We'll use this to jump into solving and using these principles as well.